Okay, so this lesson is on solving systems of inequalities. It's not too bad. I'm going to show you how to do this. All right, so what you'll be given is you'll be given two inequalities, okay? It's going to want you to graph them. So let's go through how to graph it. I'm going to start with this first one. Y is less than or equal to negative x minus 2. To graph an inequality or a line in general, you start with the y-intercept. Okay, so that's at negative 2. So I'm going to put a dot at negative 2. My slope is what's with the x. So that's a negative 1, right? So my slope is negative 1. To turn it into a fraction, to turn any number into a fraction, you put a 1 underneath. So that means my slope is going to be down 1 over 1. Down 1 over 1. Down 1 over 1. Okay, I want to go through that again just to make sure we're good. So I graphed this y-intercept first. That's where that negative 2 came from. This is my slope. It's negative 1. So that means you go down 1 over 1. Okay? What you need to know now. Remember when we graphed inequalities on a number line, if it was like this, we always shaded our circle in. If it had that line under it, and if it didn't have the line under it, we left it as an open circle. Well, it's kind of the same rules. If there's lines under it, you're going to make it a solid line. If it doesn't have lines, then you're going to make it a dashed line. Okay, so that's the difference in the inequalities. So this one has a line under it, which means I'm going to kind of connect the dots and draw a solid line through these points. Okay. And then shading, okay, if it's less than, that means you're going to shade below the line. If it was greater than, then we would have shaded above. So because this one is less than, this is the part that's going to be shaded. Okay, let's graph the next one. Again, I'm going to start with my y-intercept, which is at positive 2. So that's that green dot. My slope is negative 5. Again, to turn it into a fraction, put a 1 under it. So that means I'm going to go down 5 from this point. Down 1, 2, 3, 4, 5, and over 1. And again, it has the line under it. I'm going to do one more. I'm going to go, instead of going, well, never mind. All right, so it has the line under it, which means it's going to be a solid line. So it's going to go like, oh goodness, pretend this is a straight line. Sorry, y'all. Okay, and again it says, well, this one says greater than. Greater than means you're going to shade above it, right? Okay, your answer when you're doing these inequalities is going to be the part where they overlap, and that's going to be right in here. I'm below the purple line and I'm above the green line. So this little brown area that I'm shading in, that's where your answers are going to be. So a type of question you might have is give me an ordered pair that is a solution. So any ordered pair that would be, and you remember these lines, they keep going. They don't just magically stop because my graph stopped. These lines keep going. So any ordered pair in this brown area is going to be an answer. So like we could, excuse me, we could do the ordered pair 2, negative 5. Let me get another color. 2, negative 5 is right here. Well, that's in the brown area. So 2, negative 5 would be an answer. The ordered pair 0, 1 is not going to be an answer because that's up here and that's not in the brown area. Okay, let's do another one. Okay. So let's graph these two to start with. I'm going to make this a little bit bigger, actually. And let's move this line. So that's where I wanted it. Oops. Okay, so let's graph this. All right, I'm going to start with my y-intercept, which is at negative 2. My slope is negative 1. Is this not the exact same one? This is the exact same one. Okay, well, I'm going to make up a new one. Let's do y is greater than 2x minus 2. So we'll start off the same way. I won't have to erase that. And let's do y is, so I do 2x minus 2. Okay, so I'm going to do y is less than negative 2x plus 5. And I'm going to do less than or equal to. Alright, so these are the ones I'm going to graph. Ignore this. Okay, so again, I'm going to start with this negative 2. Let me get a different color. So I'm going to start with this negative 2, which is the dot I have. My slope is 2, which means I'm going to go, let me write it over here. You change it to a fraction, so 2 over 1. So that means you're going to go up 2 over 1, up 2 over 1, up 2 over 1. Now, this one does not have a line under it, which means when I connect these dots, I'm going to do a dashed line. Okay, and it's greater than, which means I'm going to shade above. All right, let's graph this one. I'm going to start at positive 5. There's my dot. My slope is negative 2, so I'm going to go down 2 over 1. From here, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Now it has that equal sign, which means I'm going to connect these dots. And it's a less than, so I'm going to shade here. Okay, so let's talk about where our answer is. Our answer is where they overlap. So where did I draw pink and brown? I drew pink and brown. I'm going to highlight this in this entire area here. So anywhere from here, any ordered pair in this highlighted area is going to be a solution. Okay? So if it says, you know, what's a solution to this inequality, you could pick any ordered pair in this yellow region and it would be a solution. Okay, so let's look at this. This system of inequalities is already graphed, so they graphed it for us. It wants to know which ordered pairs are solutions, so let's go through them. 0, 0 is right here. So the solution, this is your first inequality, this is your second inequality, and this dark green area is where our answers are, okay? So is 0, 0 in that dark green area? No, so it is not a solution. Negative 4, 1 is right here. Okay, here's where you got to be careful. If the dot lies on a solid line, it is a solution. If it lies on the dashed line, it is not a solution. Because, remember, your that dashed line means that it does not equal. The line underneath it, if it's solid, that means it could equal that. But if it's a dashed line and it's on there, then it's not going to be a solution. So negative 4, negative 1 is down here. Is that in the dark green area? No. Negative 6, 0 is going to be 4, 5, 6 is going to be here. Would this be in that dark green area if we extended it? Yes, it would. Negative 3, 0 is right here. Now, it's on both. It's on the dashed and the solid. So it's going to be a yes. If it's on the solid line, trumps everything. Yes, that is going to be a solution. And last, the ordered pair 4, 4 is up here. That's not even close to being in the green area, so no. Okay, let's graph this. I'm going to start with this bottom one. So it's at y is 3, so I'm going to go put a dot on my y-axis at 3. It is a less than, it doesn't have the equal to, so that means it's going to be a dashed line going through at 3. Now there's one like this on your worksheet. That's specifically why I put this here, so that you could see it. So again, I'm graphing this one. It's at 3, so I did a horizontal line through 3, and it says less than, which means this oops, everything down here is going to be shaded. Let me erase this part I went up high. All right, this one stinks because it's not in y equals. So I got to fix it. So let me write this down here. Negative 2x plus 3y greater than or equal to negative 6. So I'm going to start by moving my 2x, and the opposite of a negative 2x is a positive 2x. So these cancel, and I got 3y is greater than or equal to, I'm going to put my x first. It's a positive 2x, right? And then that's a negative 6, so I'm going to put minus 6. Next up, I want to move the 3. The opposite of multiplying is dividing, so we're going to divide by 3. So those 3's cancel. And I got y is greater than or equal to, that just stays 2/3 x. And 6 divided by 3 is 2. So let's graph this. Remember, we start with the last number, so I'm going to put a dot at negative 2. My slope is 2/3, which means I go up 2 over 3. I'm going to put a dot here. Up 2 over 3. This one does have the line under it, which means I'm going to connect the dots with a solid line. And it says greater than or equal to, so I'm going to shade above. All of this is answers. So, where did they overlap? Hopefully you see that the overlapped portion is right in here. So any ordered pair in this kind of brown area would be a solution. Okay, what happens if they don't give you a graph and they want you to see if they're answers? Well, it's not too bad. Remember, ordered pairs are always x and y. Well, actually you have two options. I guess I should first explain that. You could graph these, right? And you could then look at the ordered pairs like we did 2 problems again. Or another way you could do it is plug them in. Ordered pairs are x and y. So I'm going to do this first one. 3x plus 2y greater than or equal to negative 2. And instead of x, I'm going to do this first ordered pair. So instead of x, I'm going to plug in 0. So I have 3 times 0 plus 2. But again, instead of y is 1. And greater than or equal to negative 2. Well, 3 times 0 is nothing. 2 times 1 is 2. So is this true? Is 2 greater than or equal to negative 2? Yes. Okay, so it worked for the first one. That is true. You also have to do it for the second one. So I'm going to do this second one. X plus 2y is less than or equal to 2. So plugging in for x, I'm going to plug in a 0. I'm still on this first one. Plus 2 times y is 1. 2 times 1, oh well, 0 just kind of goes away. 2 times 1 is 2. Is 2 less than or equal to 2? Yes, it equals. So this is true for both inequalities. So yes, this one is a solution. Let me do another one just to make sure we're good. All right, now I'm going to do this one. So I'm going to do 3x plus 2y greater than or equal to negative 2. I'm going to plug in negative 3 for x. I'm going to plug in negative 2 for y. 3 times negative 3 is negative 9. 2 times negative 3 is negative 6. This gives me negative 15. Is negative 15 bigger than or equal to negative 2? No, it is not. It is smaller than negative 2. So I can go ahead and stop. If it doesn't work for 1, then you're done. It's not a solution. So 0, 1 was a solution. Negative 3, negative 2 is not a solution. Let's try 1, 1. So I'm going to do 3 times 1 plus 2 times 1 greater than or equal to negative 2. I'm doing this first one. 3 times 1 is 3. 2 times 1 is 2. 3 plus 2 is 5. Is 5 bigger than or equal to negative 2? Sure is. So it works for that first one. Let's try the second one. 1 plus 2 times 1 less than or equal to 2. 2 times 1 is 2. 1 plus 2 is 3. Is 3 less than or equal to 2? No, it's not. 3 is bigger than 2. So this is another one that is not a solution. Okay? I'm not going to do this third one. I think you get the point. And that is it. That's what's going to be on your worksheet. So go try 3.2 and let me know if you need any help.